Alright, today's objective, again, is to factor a difference of two squares, but this time we're adding exponents. We have x cubed minus 49x. A common factor is x, so we're left with x squared minus 49. We now have a difference of two squares. We keep the x. X squared, the square root is x. The square root of 49 is 7. One's plus and one's minus. So our final answer is x times the quantity of x plus 7 times the quantity of x minus 7. We have x to the fifth minus 9x. Again, a common factor is x. We're left with x to the fourth minus 9. We keep the x, and again we have a difference of two squares. The square root of x to the fourth is x squared. The square root of 9 is 3. One's plus and one's minus. So we have 3x cubed minus 27x. 3 and 27 are both not perfect squares, and they both have an x, so we can take out a 3x from both of them. We're left with x squared minus 9, because 27 divided by 3 is 9. We keep the 3x as part of our final answer. Square root of x squared is x. Square root of 9 is 3. One's plus and one's minus. Again, it doesn't matter which order. We have 5x cubed minus 125x. So a common factor is 5x. We're left with x squared minus, what's 125 divided by 5? 25. So we keep the 5x. We have a difference of two squares. Square root of x squared is x. Square root of 25 is 5. One's plus, one's minus. We have x to the seventh minus 81x. The only common term we have is x. So we're left with x to the sixth minus 81. We keep the x. We have a difference of two squares because the exponent that's left is an even number. So the square root of x to the sixth is x to the third. The square root of 81 is 9. Again, one's plus and one's minus. X squared plus 25. There's a simple answer to this. You guys are going to like it. Can not factor because it is a sum of two squares, not a difference. Okay, so we have x to the fifth minus 25x. Common term is x. We're left with x to the fourth minus 25. We have a difference of two squares because the exponent's even. Square root of x to the fourth is x squared. Square root of 25 is 5. One's plus and one's minus. We have x cubed minus 81x. Common factor is x. We're left with x squared minus 81. Perfect squares. So we have x squared, the square root is x. Square root of 81 is 9. One's plus and one's minus. We have x to the fourth minus 16. We have perfect squares for both of them. So the square root of x to the fourth is what? X to the second, x squared. And the square root of 16? 4. One's plus and one's minus. Now if you'll notice, x squared minus 4, isn't that a difference of two squares? Yes, it is. So we keep the x squared plus 4, and we do the difference of two squares step again with x squared minus 4. So the square root of x squared is x, and the square root of 4 is 2. Again, one's plus and one's minus. So your final answer would be the quantity of x squared plus 4 times the quantity x plus 2 times the quantity x minus 2. So we have x to the 6th minus 81. It's a difference of two squares because x to the 6th has an even exponent and 81 is a perfect square. The square root of x to the 6th is what? X to the 3rd. Square root of 81 is 9. One's plus and one's minus. Now, since x cubed has an odd exponent, this is the final answer.